Hey everybody, welcome back. This is Chem 300 and we're continuing chapter 5, this time talking about how to name molecular compounds. So our goals in this section are to determine the chemical formula of a binary molecular compound from the name, and then to work that backwards and determine the name from the formula of a binary molecular compound. In this image here, I put this one here to represent molecular compounds because molecular compounds are made from nonmetals that share electrons. And in our model kits, recently in the lab, we've been making models of covalent or molecular compounds that contain all nonmetals. So just a reminder of what molecular compounds are. They're compounds that are formed from two or more nonmetals. So when you're identifying something as molecular, you want to check for nonmetals. And then you want to also just do a quick check to make sure you're not dealing with polyatomic ions. If you have polyatomic ions, those contain all nonmetals, but because they're an ion, they have a charge. Polyatomic ions would be an ionic compound. So these are nonmetals that don't have ions. The basic unit of a molecular compound is what we call a molecule. So molecular compounds, they exist as discrete neutral molecules, so they won't have charges, and they're usually formed by a combination of nonmetals. So we're going to learn how to name two types of molecular compounds. We're going to learn how to name binary molecular compounds. That's the focus of this section. This is a molecular compound composed of two nonmetal elements. And then later, we're going to learn how to name acids. Acids is a molecular compound that can donate one or more hydrogen atoms, H+ ions, which we call a proton. And acid naming will be the beginning of part 3 of the chapter 5 lectures. So let's talk about naming binary molecular compounds. A binary molecular compound is a molecular compound in which only two non-metallic elements are present. So you're only going to have two types of atoms, and they're both going to be nonmetals. To name them, we use Greek prefixes to show how many atoms of each nonmetal is present. So we always place the least electronegative of the two nonmetals first. So that's going to be farthest left and down on the periodic table. And then we put the more electronegative of the two nonmetals second in the name. And then we use a prefix. So with a prefix that goes before the first element tells us how many atoms. It's the number of atoms we have of the first element, and the prefix that goes before the second element that tells us the number of atoms of the second element. And we'll be using the Greek prefixes to tell us how many of each element, how many atoms of each element we have in the compound. So there's a couple special conventions we need to talk about before we jump into naming these binary molecular compounds. The first has to do with vowels and the Greek prefixes. So if you have a Greek prefix that ends in the letter A, and then if the element name that follows that Greek prefix starts with an I or an O, then you need to drop the A in the prefix. It's to avoid having two vowels next to each other. So for example, pentaoxide would be correct, but pentaoxide with that A in the prefix would be incorrect. You don't want to have the A from penta from the prefix next to the O in oxide, that double vowel. And so we drop the A from the prefix to name it just pentoxide. So we drop the last A in the prefix if it's next to an I or an O in the element name. So you're going to see this with oxides and iodides. And then the second special naming convention is that we don't include the mono prefix on the first element. So if there's only one atom of the first element in the binary molecular compound, we don't put mono before it as the prefix. So carbon monoxide has one carbon atom and one oxygen atom. We'd name that just carbon monoxide. We don't name it monocarbon monoxide. We omit the mono from the first element. So again, to reiterate, check your vowels. If you have an A in a prefix next to an I or an O, then you drop the A from the prefix. And if you have just one atom of the first element in your formula, then you don't include mono with that prefix. Mono only comes if it's with the second element. So this is a prefix table for those Greek prefixes for binary covalent compounds. They're the same Greek prefixes that we used with hydrates earlier in chapter 5. Mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7, octa means 8, nona means 9, and deca means 10. And then here it reminds you, when the prefix ends in an A or an O, then the element names and the element name begins with A or O, then you drop the final vowel. For example, monoxide is used instead of monooxide, and hexoxide is used instead of hexaoxide. Okay, so let's do some practice with these. So we have NCl3. To make sure you're going to name this as a binary molecular compound, make sure it's first a molecular compound. If it's an ionic compound, we use a different naming system. So to check that it's a molecular compound, it needs to have all metals, which this does. It's nitrogens and chlorines. And then you want to check that there's no polyatomic ions. We don't have any polyatomic ions in here, so we're going to name this like a binary molecular compound. If it had a metal or if it had a polyatomic ion, we would name it as an ionic compound. So for the binary molecular compounds, this makes the cut. We put the name of the first element with the prefix. So we have nitrogen. And we omit the prefix mono for one nitrogen atom because it's the first element. So just nitrogen. And then we have 3 atoms of chlorine. So tri, and then chloride. And just like in ionic compounds, the second metal, the one that's more electronegative, gets the IDE ending to that metal name. So this is nitrogen trichloride. Okay, next we have P4O10. So 4 is tetra. And then P is phosphorus, so tetraphosphorus. And then we have 10 oxygens. So the Greek prefix for 10 is deca. And then oxygen is oxide. And then we have that situation where we have the A from the prefix next to the vowel O in oxide. So you want to get rid of that A. So we get tetraphosphorus dec oxide. Okay, let's go from a name backwards to the formula. So we have sulfur hexafluoride. So there's no prefix in front of sulfur, so that means we just have one of them. And then hexa means 6, and that's attached to the fluoride, so SF6. Next one, we have dioxygen. So the di goes with the oxygen, so O2. And then difluoride, F2. So there's a few common names of molecular compounds that are used in place of these IUPAC names. So you want to be familiar with these common names, so as you see them come up in word problems, you know what compound we're talking about. So H2O, we just call that water. Otherwise, it would be dihydrogen oxide. H2O2, we call that hydrogen peroxide. The IUPAC name would be dihydrogen dioxide, but we just commonly call that hydrogen peroxide. NH3, nitrogen trihydride, is actually called ammonia commonly. Hydrazine is N2H4. The IUPAC name for that would be dinitrogen tetrahydride, but we just commonly call it hydrazine. Methane is CH4. Ethane is C2H6. Nitrous oxide could also be called dinitrogen monoxide, but we commonly call that nitrous oxide. And then nitric oxide is NO. We could call that nitrogen monoxide, but it's most commonly called nitric oxide. So just be aware that there's a few of these common names around where you might see the common name substituted in place of the IUPAC name. So that's it for molecular compounds. They use the Greek prefixes. So if you see a compound that's all nonmetals and it has a Greek prefixes, it's going to be named as a binary molecular compound. Next, we're going to talk about acids in the next section. That's our second type of molecular compound. And we'll pick it up there next time. Thanks, everybody. Bye.